lecture and I think the next lecture are both on C-style strings. All right, so strings in Java are just sequences of characters. Sorry, strings in C are just sequences of characters. Right? And characters are just integer values, right? So you know the type char is an integer type. Right? So the way you end up with printable text is that these integer numbers, they just get mapped onto their corresponding character values. Right? And it turns out the way this is done is with what's called an encoding scheme. Right? So you take a number, map it to a character. Right? And there's lots of different encoding schemes. Right? So an older but very common encoding scheme is called ASCII. Then there's extended ASCII, and then there are these UTF things, which are all Unicode. C doesn't say which encoding is used C does not specify the encoding for translating integer values to their corresponding characters. So C says you can use whatever encoding you want. The compiler can use whatever encoding it wants. The language doesn't specify the encoding at all. Right? And this is very different than Java. Java says everything shall be UTF. I don't remember if it's 8 or 16. Java is Unicode. I don't remember which version of Unicode it is. Right? But Java says all strings shall be Unicode encoded. Right? In C, that's not the case. Right? Now we're not really going to worry about that. So we're not so concerned about the particular encoding that's used in this course. You have to be aware, though, that it's possible when you're programming professionally, you might have to deal with a different type of encoding. Okay, so for our purposes, all strings are arrays of char, right? And that's good enough for this course. But the C standard does say that you can represent characters in different ways, right? So strings can have different representations, right? They could be arrays of char. They could be arrays of int. There's this type called wchar, which is wide characters. Right? There's char 16 and char 32. So 16-bit characters, 32-bit characters. Right? And again, which one you choose to use, well, it's up to you. Right? As far as we're concerned, though, strings are just an array of char. Now, the weird thing in C is that there is no actual string type, right? Which is strange coming from languages like Python and Java, where strings are first-class types. Right? So instead, the C language says, look, strings are just arrays of characters, right? And you have to deal with all of the limitations that come with that, right? So what are the limitations? I can't resize a string, right? Because I have to resize the underlying array, right? I don't know how big a string is. I don't know how many characters are in a string because the language doesn't keep track of how many characters are in the string, right? If you're lucky, you might happen to know the size of the array, but that doesn't tell you the length of the string, right? It just tells you how big the string might be. Right? And so there's all these limitations that come with this representation. Now to help you deal with this sort of thing, the language provides you with a library that can operate on arrays of characters. Right? And if you look at the header file string.h, you'll see that there are different versions of the functions for regular strings, where they're just array of char, right? And then the wider strings, which are array of wchar, right? Again, we don't care about the wchar functions, right? We only care about the char ones, right? But you'll see there's multiple versions of every function, and that's because they have to provide a function for every possible character type, right? Again, no generics in C, so there's no proper generics in C. So there's no way to write a function that can work with any string type, any character type. All right, so you already know that a proper C string is always null terminated, right? So the last character, the end of the string is marked with the literal value 0, right? Which if you write as a char literal is \0. Right? You have to remember that because your strings are just array of char, you have to leave one extra space for that terminating character. Right? Now the weird thing is that the last character in the end of the string, the last character in the array is not necessarily the null character, right? All that matters is that there's a null character somewhere in your array, and that null character marks the end of the string, right? So there can actually be more than one null character in an array. Generally, you want to avoid reading past the first null character. Now, strings in C are null-terminated arrays of car, but there's nothing from stopping you from making an array of car that's not null-terminated, right? So I can make an array of car, store a bunch of cars in there, but I can't treat it safely as a string. Otherwise, the standard library functions will probably fail when you pass in such an array, right? So it's really important that you remember terminate your strings with a null, with the character value 0. Okay. When you talk about the size of a string, then that's normally, in C, that's normally the size of the array, right? So here I've got an array of car, right, of size 16, right? So the size of this array is actually 16, right? The length of a string, that's the number of characters before the first null character, right? So if I take my array and put an A in for the first element, a B for the second, a C for the third, and then the fourth character is my null terminator, right? The size of this array never changes, right? So when I run size of S, it's always 16. When I run the string length function, which tells you the length of a string, right? In this case, it's 3. 1, 2, 3. Right? If I move that 0 somewhere else, I can change the length of the string. Right? So for example, if I move the 0 to here, right, and move the B to here, then the length of the string is still 1, right? Because it's just the number of characters before the first null terminator. Right? If you move the null terminator to the front, then the length of the string becomes 0. Right? The size of the string, the size of the array, though, is still 16. Right? So there's a distinction between the size of the array and the length of the string. String literals in C are just things that are double quoted, right? So a sequence of characters that are double quoted is a string literal, right? The compiler sticks the null terminator on the end for you, so you don't have to try to put in the null terminator yourself, right? When you make a string literal, right? And the size of the literal, so the size of the array that gets allocated for the literal is equal to the number of characters in the literal plus 1, right? Plus 1 for the null terminator, right? So here we've got a string literal, right, ABC, right? It's stored in an array S, right? In this example here, the compiler knows that the string, this is a literal, so it has length 1, 2, 3, right? But it makes an array of size 4 because it adds the null terminator for us, right? So S is actually an array of size 4. When you run that line there, it'll print 4, right? String length will be 3, right? You can do something weird like this. Right? So I can make a literal, A, B, C, null terminator, right, DEF, right? Compiler silently inserts another null terminator at the end of this thing here, right? The size of this string is 1, 2, 3, 4, 5, 6, 7, and then 8 for the extra null terminator. The length of the string, though, is 3, right? So the compiler just sticks the null terminator at the end of the literal, right, and then makes an array that can hold all the characters, including the extra null, right? Okay. When I use size of here, you have to be careful when you use size of, though, right? So when you use size of and you ask for the size of an array, right, it only works correctly if the array is locally allocated, if it has automatic storage, right? So in other words, if you try to dynamically allocate an array and you ask for the size, right, then you get the size of a pointer, which is 8 on my machine. Right? So size of returns the expected size of a string if the string is referenced via a statically allocated array variable. If you use a pointer variable, then size of returns the number of bytes needed to store the pointer. So for example, right, there's my array, S, right? So if I use size of S, in this case it's 4. String length is 3. Right? Here I have a pointer. Right? So this is a pointer to a string literal. Somewhere in memory there is an array of size 4 that holds ABC, null terminator. Right? But here I only have a pointer to that array. If I ask for the size of S2, it's not 4. Right? Instead what you get back is 8, on my computer anyway, probably your computer too. Right? You get back 8 because 8 is the size of the pointer. Right? So pointers on my computer, probably your computer, are 8 bytes long. Right? Here, if I have a pointer that's not a pointer to a car, right? In this case, it's a void pointer, right? That's also 8, right? So all pointers on your computer probably have this. All pointers on your computer have the same size. On most of your computers, it's probably 8. Right? So be careful about confusing. You have to be very careful when you use size of. Right? All right. So all of your string functions, I think all of them, are defined in are declared in string.h. Right? And you can just click the link there, and that will take you to the page that describes all of the string functions. So there's different things that you can do with strings. You can classify the characters in a string. Are they uppercase and lowercase, for example? Right? You can manipulate the characters, so convert a character from lowercase to uppercase and vice versa. You can convert to the various between numeric formats. So you saw this in one of the assignments where you used A to I or A to F to convert a string to an integer or a float. Right? You can manipulate strings like replace characters or search for characters. And then you can manipulate arrays of characters, so memcopy and memmove. String length is probably the one you'll use the most often because often you'll need to know the length of a string. Right? So string length just returns the length of the specified null terminated string. Right? So you pass in a pointer to car. Right? Presumably when you pass in this pointer, it's pointing at the first character in the string. Right? It assumes that there's a null terminator marking the end of the string. String length returns the number of characters before the null terminator. Right? Now notice the weird thing about string length. So how do you implement this if you don't know, if the language doesn't store how big a string is? Right? The only way to implement string length is to loop over the array and look for the null terminator, which sucks because that's on in the length of the string. Right? So just to find the length of a string in C, you need to search for the null terminator in an array, right? Which is going to take time, has complexity big O of n, where n is the length of the string. Right? In Java or Python, the string classes store the length of a string. Right? So you just look up a field that has the length of the string. Right? So there, in those languages, it's always O1. Now, string length assumes that string there actually has a null terminator in it. Right? If you have reason to believe that there might not be a null terminator in that string, then there's a different version of the function that you can use. So there's this function called str, and notice the only difference, there's an n in it, right? String length s, right? So that version of the string length will search that array, but it'll only search up to n characters in that array for the null terminator. Right? So this one will just keep on going until it sees the null terminator. If you don't have a null terminator in the string, it'll go past the end of the array, and then bad things can happen. This one will go only n characters into the string, and then it'll stop. Okay, so how do you implement string length? So, I mean, you just have to search an array for the null terminator. Right? So the obvious way to do this is to use a for loop. Right? So start at index 0. Right? Look at stri, so the ith character of the string. Right? If it's not the null terminator, add 1 to I. Right? And then the while loop keeps on going, right? Until it sees the null terminator. Right? When it sees the null terminator, you know you found the end of the string, so you can just return I as the length. Right? So here I is just keeping count of how many characters you looked at. Right? So that's the quote-unquote obvious way to implement string length. It's not the only way, though, because this is C. Right? So you can use a pointer instead. Right? So again, start out with I at 0. So I'm going to start by looking at the first character. Right? How do I get the first character of an array or of something pointed at by str? Well, I can dereference str. Right? So star str, that gives me the character that str is pointing at. Right? I'm going to check, is that equal to 0? Right? If it's not, add 1 and keep on going. Right? Add 1 to I and keep on going. Now this thing is a bit strange. Right? str++. So what exactly does that do? What does ax++ do in any of the languages that you've used so far? Anybody know? What's the value of x? So if x is 1, what's the value of x++? It's 1. right? Okay, so in any of the languages you've learned so far, right, if x equals 1, right, then int y equals x plus plus, right, y is 1. Right? That's the value of 1. Right? So that's the way this particular operator works. Right? Plus plus, if you write it after the variable name, is called the post increment operator. Right? So what does it do? Right? Post increment operator, so I think as far as most of you guys know, it changes the value of x by 1. Right? But when does it change the value of x by 1? Right? So because you wrote plus plus after, it does it after you get the value of x. Right? So what this says here, get the value of x, store it in y. So y is 1. Then, after you've used the value of x, add 1 to x. Right? So y is 1, x is 2 in this case. Right? So what does this thing here do? So star str plus plus. Right? So it turns out the dereference operator has higher precedence than plus plus. So whoa, sorry. Where'd we go? Oh, we went really far. Okay, so star str, dereference the pointer to get the character. Right? So in this case, I get the first character of the string. Is it the null terminator? Yes or no? Keep on going. Right? Right? After dereferencing after dereferencing and using the value, right? Add 1 to the pointer. Right? In other words, move the pointer 1 to the right. Right? So C lets you write very concise code. Right? This is not something you'd ever show like a brand new programmer, right? But it's something you need to know about. Question? Can you do plus plus? Yes, what does plus plus do? Exactly, int z. Okay, so remember x is 2 at this point. If you write z equals plus plus x, z is 3, and x is 3. Right? So plus plus in front means update the value of x first, and then return its value. Right? X plus plus, use the value of x first, then update its value. Right? And so that's the difference between the two different plus plus, and minus minus works the same way, those two operators. Right? That's postfix, post-increment, pre-increment. Right? There's post-decrement and pre-decrement as well. So that's the difference between those operators. Right? For the most part, when you use those operators, you're just using it to increment x. Right? It's a little unusual to use the value of x as well, and then do something with it. Right? But you will encounter it not just in C. You'll encounter it in Java and Python as well. Normally, the people who write that sort of code well, they've learned this before. Right? Whether they learned it the hard way or the easy way, they've learned it already. Right? So it is important that you, at some point, learn to translate what that means by understanding exactly what the operators do. Right? Okay, there's other ways to implement this code. Right? So I can use a for loop. So here I'm going to start with a pointer s. Right? I'm going to initialize s so that it points at the whatever character str points at. Right? Now, when should this for loop run? Right? This for loop should run as long as as long as s is not pointing at a null terminator. Right? So as long as it's not pointing at a null terminator. So in other words, as long as it's not pointing at the value 0. Right? So star s, that's the value that s points at. Right? If this is 0, then that's equivalent to false in C. Right? If it's not 0, that's equivalent to true. Right? So as long as this is not pointing at 0, this loop runs. Right? Each time you just advance the pointer by 1 to the right. Right? So as long as it's not pointing at the null terminator, advance the pointer 1 to the right. Inside the loop, there's nothing to do. Right? This loop runs until s points at the null terminator. Right? Now, how do you get the length of the string? So what's going on here is the following. So we've got some string here, A, B, C, and then the null terminator. Right? So str, that's a pointer. right? So str points at the A, right? S starts by pointing at str, right? So it's also pointing at the A, right? The loop condition says, is S pointing at, is S not pointing at 0, right? So the answer is yes, right? So advance S by 1. So S moves to the right by 1. Let me draw it this way, sorry. Right, so is S, when you dereference S, is it pointing, sorry, does S pointing at 0? The answer is no. So move S to the right by 1. So S goes to here. Right, and then is S pointing at 0? The answer is no. So move S to the right by 1. Right, is S pointing at the 0? The answer is no. So move it to the right by 1. Is S pointing at the 0? The answer is yes. So stop. Right. So what do we return? We return S minus str, right? So remember what pointer subtraction does in Java? In C, in Java, right? S minus str returns the number of characters, returns the difference between S and str, right? So if str points at the front of the string and str points at the back, right? The difference, S minus str, is just that. Right, the number of characters that are, the number of characters between S and str. So there's 1, 2, and 3. Right, so that's the length of the string. Yes?
So if you hypothetically replace the B with a 0, not the null terminator, just a 0, would this code still work?
You mean the car lit? So there's a difference between that and that. That's the number 0. That's the character 0. So if I put the character 0 in, so I put the character 0 in, then it's still 3. Okay. Yeah. The null terminator as a character literal is that. As an integer value, it's 0. I don't know what the integer value corresponding to that is in your computer. Right. All right. Any other questions? Okay. Whoa. Sorry. Okay. So that's getting the length of a string in 3 different ways. Right? You could probably come up with many different ways to write that loop. But in every case, you need the length of, you need to write a loop. Okay, now what about copying strings? So in Java, you never copy a string, right? Because Java strings are immutable. Same is true in Python, I believe. Right? So you never copy strings in either of those languages. In C, though, it's often, actually in both languages, it's sometimes useful to copy a string in all these languages, right? So if you want to actually copy a string, right, what do you have to do in C? Well, I have to copy the underlying array, right? So instead of copying the array yourself, there's a function that does it for you, right? So strcopy, it'll actually copy a string or a part of a string into another string or into part of another string, right? So src, that's a pointer into the string that you want to copy, right? Dest is a pointer into the string where you want to copy, start the copying into, right? Normally, str points at the front of the string to be copied. Normally, dest points at the front of the string where you want to copy the string into, right? But it doesn't have to. Right? Okay, so the way this works is it just copies characters from ser into dest until it sees a null terminator in src. Right? So it's going to work the same way as, similar to string length. Right? Now the problem with this function is, right, you don't actually know how big the source string is. Right? Remember, C doesn't keep track of how big the source string is. Right? So all this does is it blindly copies characters from here into here. Right? If that string is longer than that string, right, then bad things happen, right? Because you end up running past the end of the array that dest points into, right? So that's not good. So behavior is undefined if dest is not large enough, right? You also can't copy a string into itself with this function, right? So source and dest are not supposed to be pointers into the same array, right? And if you think about that for a second, you'll realize why, right? So they can't overlap. Right? Or it's not a point, right? Other things that could happen, if source is a pointer into a car array but it's not null terminated, right? Again, it's just going to keep on going until it actually sees a 0, right? Which might go past the end of the array. That's bad, right? Dest is not a pointer to a character array. Sure. And if that happens to be not a pointer to a character array, bad things can happen as well, right? This thing returns, it just returns a pointer to dest. Right, so how do you do this? Well, assuming everything is fine inside SRC and DEST, right, you're just going to loop over this until you see a null terminator, copying characters into destination. Right, that's what these are short for, right? Source, destination. Right? So start with I, right? I is going to be 0, right? Notice I can't declare int I here, because I need I after the loop, right? I need I after the loop because I need to set the null terminator, right? So I need to remember where have I actually gone into, what is the character one past the last character I copied in dest. So I'm going to need I, right? That's why I'm starting with I outside the loop. So I starts at 0, so it's going to start at the first character of SRC, right? So while SRC is not the null terminator, right, each time advance I by 1. Right? So if SRC, that pointer is not pointing at 0, copy that value into the destination array. Right? Just keep on going until this value here is actually the null terminator. Right? So we're not going to copy the null terminator in this example here. Right? And then finally, as the last step, make sure that the null terminator gets copied into the destination. And then finally, you just, for some reason, this function always returns a pointer to that there. Right? So now return dest. Right? So that's one way. So that's the quote unquote obvious way of implementing this loop. Right? Just loop over source until you see a null terminator. Right? Again, being C, there's lots of different ways to write this. Right? Okay, so here we go. So I'm going to make a pointer called save, yes, called save, right? And I'm going to start that by pointing at dest, right? Now remember, this function always returns that pointer, right? So I'm just going to return save at the end. The reason I need save up here is because here I'm going to manipulate dest, right? So I'm actually going to change the pointer DEST, right? Okay, now what is this thing doing, right? While star DST++ equals star SRC++, right? Okay. So what exactly is this doing here? Right? You've never, I'm pretty sure you've never seen this type of condition before. Right. Okay, so SRC is here. Right? And DEST is over here. Right? So this is my destination array. This is my source array. Right? So the source starts pointing there. Right? Dest points there. Right? Save is going to be equal to dest. Right? So save is going to be pointing also to there. Right? Now what does this loop? Whoa, sorry. What does this loop do here? Okay. So we have a star dest, right? So dereference the pointer, right? We got star SRC, so dereference that pointer, right? So I dereference SRC, I get an A, right? I store that, right, into whatever dest points at, right? So that's going to store the A in the first character, right? So dereference source to get the A, store that wherever dest points at. Then there's a plus plus and a plus plus. So that's going to advance dest and source in a second. Right? Now, this doesn't look like a condition. Right? But it turns out in C and actually in Java, I don't know if it's a condition in Python, but in C and Java, this in fact does return a value. Right? Actually, this doesn't work in Java. This works in C. Okay, so what's going on here? So you've got something here gets assigned a value here. Right? So you can read this as just being x equals y. Right? X gets assigned the value y. So in C, the value of an assignment, right, is just the value of x after the assignment has occurred, right? So what does all of this evaluate to? Right? If you just imagine this is x equals y, right, then that's the same thing as saying this is equal to a, right? The value of the assignment is just equal to the value of that, right? So that's just going to be equal to a in this case, and then advance the pointers, right? So is a 0, right? Remember, 0 in C is false, right? Anything that's not 0 is true. A is not 0, so keep on going, right? So that thing does not evaluate to true, it evaluates to false. Right. Sorry, it evaluates to true. I'm sorry, it evaluates to true. Right? So in this example here, right, the assignment evaluates to the character A. A is not 0, keep on going. Right? So advance the pointer dest and advance the pointer source. Right? So now source and dest both move one to the right. So now source points there, and dest points here. Right? Once again, right, dereference source to get the B, store that in whatever dest points at. Right? So B goes over here. What's the value of the assignment? The value is equal to B. Right? Is B 0? The answer is no, so they keep on going. Right? So advance source and advance dest. That, right? Dereference source to get the C. Store that in whatever dest points at. Right? So C. Right. Is C equal to 0? The answer is no. Right? Or is C true? The answer is, sorry, is C true? The answer is true, yes, right? Because it's not 0. Right? So keep on going. Right? Advance source and advance dest. Right? Okay. Dereference source. So now I get the 0. Copy it into whatever dest points at. So that copies the null terminator in. Right? What is the value of the expression? Well, it's x equals y. I just copied a 0. So the value of the expression is 0. 0 is false in C. So the loop stops. Right? But dest and source both get incremented. Right? Because you're using the post increment operator. So source actually goes to here. Right? And dest actually goes to here. Right? And now if you remember from about 2 or 3 weeks ago, I told you about something called the, you're allowed to advance a pointer 1 past the end of the array. Right? Source is now the too far pointer. Right? Remember the too far pointer is the pointer that's 1 past the end of the array. Right? And that's what source is. The language says this always works. Can't use source for anything, but this is legal, right? And that's why it's legal. It's because people used to write code like this, right? Where you'd advance a pointer past the end of a string, 1 past the end of a string. All right, so am I saying you should write code like this? No, I'm not saying you should write code like this. Am I saying you might see code like this? I'm saying yes, you may see code like this, right? It's important that you understand exactly what the language is doing in order that you can actually understand code that happens to be written like this. Right? There are coding standards that probably say don't write code like this because it's too hard for many programmers to understand. Right? Any questions about that example there? Yes?
Is this like any faster to, writing it kind of?
No, it's not any faster. Probably generates the exact same machine code. Or a good compiler would probably turn it into the exact same machine code. It's not any faster. When you get used to it, it may be easier to read, maybe. But for most people, right, you have to stare at that for a second and say, oh, what is this doing? Right. Right. So I'm not advocating you write code like this. But at some point, you have to be aware that code like this exists. Right. All right. Why do I need string copy if everything's just an array? Right? And the answer is because you can't assign arrays in Java, in C, sorry. I really should not teach 124 and 220 at the same time. Okay, here's an array, right? S is an array, right? So what does this mean in C? It means, well, S is an array, right? It also means you can't assign anything to S, right? So if you try to do any assignment to an array variable, that always fails in C, right? You are not allowed to assign to an array variable, right? So there's no way for me to use S and have it refer or point to or be a copy another string, right? Because assignment doesn't exist for array type variables, right? Therefore, you need some function, or you have to write some code that copies a string for you, right? So if I want to copy the string hello into S, I have to use string copy, right? Or you have to manually set the elements of S yourself, right? You don't want to do that. Use string copy, right? Can I make a copy of this array like so? The answer is no, right? I cannot assign an array to another array in C, right? It doesn't work. Right? You can assign a pointer to another pointer, but you cannot assign an array to another array, right? So you have to copy into the array, right? Notice you can't string copy into an empty array either. So you can't make an array char t, semicolon, and then copy into T. That's not going to work, right? You have to make an array that actually has some space in it, then copy the string into that array. Okay, strn copy. You're going to see this a lot when you work with the string methods functions, right? There's a version of the method called something, and then there's a version of the function that has an n in it somewhere, right? Whenever you see the n, that means there's some sort of counting going on, right? So strn copy will copy at most that many characters from here into here, right? And so this one sort of tries to avoid the problem of when src might not be null terminated properly, right? Or could be longer than the destination string, right? So you probably know how big your array is if you're calling this function, right? So you probably know how big dest is, right? And that means you can safely pass in the size of dest, and that will prevent this function from copying more characters from here into here, right? And so this is considered quote unquote the safe version of strcopy, right? strcopy just copies everything from here into here with no regard to how big the destination array is, right? strn copy actually tries to use the information about the possible size of the destination array, right? Otherwise, they behave the same, right? The implementation is almost the same as well. You just have to respect this variable called count. This one says strn copy lets you copy a substring of string into a destination, right? But so that's one of its uses, right? So I can copy. So strn copy is the version of the function you want to use if you want to copy part of a string into another string, right? So for example, here's my string s, right? It's the characters 0 through 9, right? Here's my array t, which I also want to be a string, right? Now, notice there's a bunch of comments down here. We'll get that in a second, right? If I want to copy 3, 4, 5 into t, so I want to copy part of this string into t, right? Then I can use strn copy to do so, right? So t, this is the destination pointer, right? So I want to start copying into the front of t, right? Where do I want to start copying from? Well, I don't want to start copying from the 0. I want to start copying from the 3, right? So the 0 is pointed at by s, right? Plus 1, plus 2, plus 3, right? So s plus 3 points at the 3, right? So I can pass that pointer in for the source pointer. And then 3 is the maximum number of characters to copy, right? So that will copy the 3, the 4, and the 5 into t, right? But that's all it does. It copies the 3, the 4, the 5 into t, right? It doesn't put the null terminator in for you, right? If you copy all the characters of s, including the null terminator into t, that copies the null terminator into t, right? But if you don't, right? In this case, we're not. We're doing the 3, the 4, the 5. You have to put the null terminator in yourself, right? So I have to put a 0 after the third character in the string. Right? Now I can safely call functions like printf or string length or whatever else I want using t. Right? But string copy does not necessarily copy in the null terminator for you if you only copy in a substring. Right? So that you have to be careful of. Right. Notice this. Right? If someone doesn't tell you this and you just read the documentation of strncopy, you probably wouldn't pick up the fact that the null terminator is not always copied in. Right? If you don't copy the null terminator in, then any function that expects the null terminator is going to barf when you pass it a t. Right? So strncopy receives a lot of criticism on the internet because it does not guarantee null termination of the destination string. Right? It also doesn't work if src is shorter than count. It does unnecessary work if src is shorter than count. Right? However, it's part of the standard library. Right? If you want versions of the function that actually try to avoid these problems, then there are non-standard functions that you can use. Right? strlcopy, right? strncopy underscore s, snprintf, and snprintf_s are all alternatives that you might consider to using compared to strncpy. Right. Okay. What if I want to join two strings, right? Python, Java, easy, just use plus, right? You can't add two arrays in C, so you need a function that does it for you, right? strcat takes the characters of src, adds them to the end of the null terminated string pointed at by dest. Right? So you have to read the documentation carefully for this. Right? So copies the characters from here into the string into dest, but here dest is a null terminated string. Right? So it starts copying the characters of src onto the end of dest. Right? And so what does that mean? Dest had better be null terminated, and src had better be null terminated. And there had better be enough room in dest to hold everything in src after I copy all the characters of src onto the end of dest. Right? Very complicated, right? But you have to keep all of this straight in order to use this function. Right? Okay. So here we go. Here's my string s. Right? It has length 11, right? So I can store a string of length 10 safely in this string s. Right? So here I have a string of length 5, so that's fine. I've got another string t, right? 5, 6, 7, 8, 9, null terminator. Right? I want to take the characters from t and add them to the end of s. Right? So I want to take the characters t, add them to the end of s. Right? So strcat is the function that does that. Right? So it just loops over the destination string. Right? So 5, right? Is 5 the null terminator? No. Okay, add it to the end of this string here. Right? So overwrite the null terminator that's here with the 5. Right? 6, copy to the end of this one. Right? 7, copy to the end of this one. 8, and then 9. Right? And then the null terminator. So copy the null terminator into here. Right? So in total, that's 11 characters stored in the string s, which is fine. Right? Because s can store 11 characters. Right? The digits 0 through 9 plus the null terminator. So that's fine. Works just fine. Until you change that 11 to something smaller. Right? So as soon as you change that 11 to something smaller, right, the null terminator doesn't get copied in properly. Right? The null terminator gets copied, it just doesn't get copied into the array s. Right? So, for example, what's s? S is 0, 1, 2, 3, 4. Okay, so 0, 1, 2, and 3, 4. Null. Okay, so suppose that's my character array s. Right, so car s 1, 2, 3, 4, 5, 6, 7. Right, so that's my, and now I call strcat. Right, what does strcat do? It takes the characters from t, copies them into s until it sees a null terminator in t. Right, so it takes the 5, blows over the null terminator here, right? Then the 6, right? Then it tries to write a 7 here, and then an 8 here, and then a 9 here, and then a null terminator there, right? Those values there, right? They're not part of the array S, right? They're just whatever memory happens to be after the array S, right? But they get overwritten. If there's something important over here, right, that information gets overwritten, right? If you try to print this string S, right, there's no guarantee that it's going to work, right, depending on what happened when this happened here, right? Because writing past the end of the array leads to undefined behavior, right? So you never know where that null terminator is going to end up, right? And so bad things happen here, right? So strcat, this isn't safe either, right? It doesn't respect the length of the string S, right? There is a version, though, that does respect the string of the length S. It's called strncat, right? But like strncopy, it receives a lot of criticism. Right? So strncat, this is the one that copies you specify how many characters to copy. At most, how many characters to copy. Right? Do I have I don't have a slide here that describes what it is. Hang on, sorry, it's useful if we pull up the documentation for it. And I don't want that one, I want that one. No, not that one. String, where's the one for C? Well, let's try this one and see what I get. Okay, perfect. strncat, okay, number 1. Okay, so again, it has copies from here, the source, into the destination, right? That many characters, right? So if you read the documentation, it says, appends at most count characters from source into dest, stopping if the null character is found, right, in source, right? Okay, so the problem with that is that count is the number of characters to copy, right? You have to look at the documentation to know that it's the number of characters to copy. A lot of programmers assume that that count is the total size of the destination string, right? It's not the remaining size of the destination string, right? And so count is incorrectly interpreted as the maximum size of the destination string, which is definitely one way that they could have written the function, but it's not, right? And they end up passing in the wrong value for count, right? If you want the safer version of that function, there's another one for you, right? It's strncat_s. Right? What's this one do? So here's an example of using strncat, right? So here, I think that I want to append into this string s, right? I know that at most this can hold 10 characters, so I use the number 10 here as the argument to count, right? Which is incorrect, right? The correct number here to pass into strncat is 5, right? How many more characters can I write into s before there's no more space, right? But it's easy to make the mistake of passing in the size of the array minus 1 instead of the number of remaining spaces, right? This looks like it should work, but it doesn't work, right? This goes past the end of the array s again. I guess it's 20 after, so I have to stop there. Any questions? All right, we'll pick this up tomorrow.